Oíste, Darío, nos acabamos de fajar buen podcast, pues estamos haciendo aquí la introducción en español, pero
Claro.
yo creo que una de las cosas pues que tenemos es que pues, tenemos buenas conversaciones, pero hay veces llegamos y les pegamos a los que están cambiando pues de verdad el mundo, la industria. Pues acabamos de entrevistar y hablar, y eso es lo que van a ver en este episodio, por el fundador de Nosana, que es básicamente el Airbnb de GPUs. Entonces vemos todo lo que está pasando desde XI con Colossus,
Sí.
Meta, sus LLMs, OpenAI, y todo el mundo dice, bueno, y eso solo son para las compañías grandes de California, para los Teslas, para los Facebook. No, no, esta tecnología, una de las grandes cosas que tiene es que va a hacer que, yo no voy a decir productividad, pero digamos que los actuales problemas y mejoras que estamos pensando podrían ser 2 o 3 veces mejor en 5 o 10 años. Ahora tenemos un agente de inteligencia que nos va a hacer que esos problemas sean 5 o 10 veces mejores. Entonces, ¿cómo afrontar un mundo con una tecnología que nos permita tener este acceso? Yo traté de que la conversación no fuera muy técnica, inclusive utilicé el ejemplo de un amigo mío que tiene una clínica de radiología, un radiólogo, y yo le he dicho hace mucho tiempo, vos ya sos obsoleto, vos lo que deberías hacer es, porque como estás en el chat, empezar a pensar cómo construir un agente para que puedas hacer diagnóstico. Y ahí me salió ahí con un montón de babosadas, pero es parte, digamos que del desconocimiento, pero este man claramente dijo, sí, el man puede conectar un agente y luego va a correr las inferencias con nosotros. Entonces, eso quiere decir que va a tener un mejor diagnóstico, porque es un LLM entrenado con los mejores médicos del mundo, pero corriendo las inferencias. Y cuando digo corriendo las inferencias es pensando para dar una respuesta, pero está pensando con los GPUs de muchos jugadores. Dato curioso que no sabíamos, dice, hay más processing power en los GPUs de los jugadores que en los mismos data centers que hay. Y entonces lo interesante es que uno llega, entonces uno podría tener los GPUs de los jugadores que hay en Colombia, Argentina, Brasil, que están ahí arrumados, cogiendo polvo, conectarlos y llegar y decir, qué interesante, contribuyamos con nuestra inteligencia, que es puro hardware, con una conexión de internet, y me van a pagar en Nosana. Y la clínica de radiología tiene que pagar en Nosana para poder correr esa pregunta. Y eso es lo que esto está permitiendo. Y me parece pues súper bacano. Además que el man quedó como muy entusiasmado, con ganas de venir a Colombia y darse un vueltoncito por acá.
De hecho, eso que estás diciendo de los gamers, pues se lo recomendamos a la gente que vean el primer episodio de NVIDIA, porque ahí específicamente es cuando nace el proceso de NVIDIA a través de los gamers. Entonces tiene mucho sentido.
Bueno, dejémonos con ese abrebocas y vean el episodio. Obviamente es en inglés, porque pues, ¿qué vamos a hacer? Ese conocimiento está en inglés y eso traducido. Primero nos demoramos mucho tiempo traduciéndolo y...
lo ponen subtítulos en YouTube
listo.
Y es comprensible. ¿Listo?
You know how happy we are of actually having you here, because you probably don't know that even though that this is a Spanish-speaking podcast that focuses on business and technology, and sometimes is the number one in Colombia, has a heavy fan base of Nosana right now. So to the point that we talk in our chat, which is about 85 people during the day. Nosana is probably mentioned 2 or 3 times a day. Someone eventually sends us a rig. Hey, look, I'm putting together a set of GPUs, and this is one of the cool things when you build on the blockchain, that from parts of the world that you did not expect, you grow a fan base. So I've seen you on podcasts speaking in English, but I then realized, and I told my co-host Dario and Gordo on the other side, hey, we should probably invite Jesse, because everybody's asking me about Nosana, about the tokenomics, about how you do staking, but I'm not the founder. I'm just a hobbyist, an aficionado that happened to read about Nosana because I invested initially in Render, but I did not like that it was a project that was not native on Solana, and still had to migrate. And like once we found you, we took a big bet, and that's the reason we ended up connecting with you. And the other thing that I'm super excited is that I think we're going to meet each other in person in Breakpoint next week, right? Are you going to be Token 2049 in Breakpoint?
For sure, yeah. I'll be there all week, so we can definitely meet up. And indeed, I'm really happy to hear that there's such a big community, and surprised in Colombia and Southern America. Like, I've never been there, so it's amazing to hear. It's a good reason to visit.
Well, if you ever want to come, I'll set up a meeting venue, and we'll bring everybody that's excited about Nosana, that is actually building, that is on test right now, because you'll be surprised. There's more people, not only people here in Colombia, but in Argentina, in Brazil, and very awkwardly, there's not enough of this type of good content in Spanish-speaking podcast, but we throw every 5 or 6 episodes a version in English, and then we do our best to translate it and cut it and slice it in TikTok. But anyway, let's get to the meat of the of why we are here. So I'm going to ask the typical question, because most everyone that actually follows or has invested in Nosana has never seen your face. So why don't you tell us kind of like the genesis of how Nosana got started, and a little bit of your background. What was it that you were doing in the early years that you ended up creating Nosana?
Of course, yeah, I'm not that famous yet, so I'm always happy to introduce myself and tell a bit of my background. So I have a history in artificial intelligence. So I think I was like 18 years old when I started studying AI in university. This was a very small study back then. I think we were one of the smallest, least popular classes in all of university. We had like 20 people in class. These days, AI is the most popular. You need to like pre-register, and there is like a lot of resistance. And to get in that study is really difficult. But anyways, these were different times. And I really enjoyed like working on AI. It's very practical, like mathematical based. So I was just felt really at home in that industry. And I've also been always very interested in blockchain, like since early days, Bitcoin, from a technical perspective, not so much from an investment perspective, but like, you know, as a geek toying around with this open source software that can replace banking, it just really caught me. And I spend a lot of hours just toying around, and I really like this freedom idea. Like, so I wanted to combine these two technologies already quite early on. But when I was doing my master's AI, I could already sense a bit how big AI was growing. I remember we were like in the computer vision lab doing our research there, and like building.
And where was this university? Where did you go to university?
Amsterdam. So Amsterdam University. I'm born and raised in Amsterdam. So yeah, and we were in the lab building deep learning models. And one of these things that was already nagging us back then was that we just didn't get the right GPUs. I mean, the university has a GPU cluster, but still we couldn't get our hands on enough training time on those GPUs to actually build our research like we wanted to. And this was like 10 years ago. Wow. But it was a big frustration point from our end back then. And I think those are kind of the roots where the Nosana idea came from.
So it's basically the frustration of you not being able to access the clusters from the university because they were limited. I mean, you had a limited in hardware, no availability.
Yeah, you have the whole unit, like a lot of students trying to access the same GPUs, of course. And the GPUs are like, there's just been this acceleration in the hardware available. So if you look at the devices you needed back then to train a specific algorithm, they were just quite expensive and hard to come by, and you needed loads of GPUs connected together. And there was lots of smart people in the deep learning labs there. We're all like kind of, you know, creative and thinking of new things to build. But the big frustration point amongst us was just GPU access back then. And over like 10 years time, artificial intelligence has become 1 million times more advanced. It's like an insane growth. Like, so 10 years time, about 1 million times more like capable AI models. And not only that, like the number of AI models being released is also growing exponentially. So like fundamental models are being released really rapidly these days, which are models that take a lot of energy to train and use. So yeah, that came kind of together after ChatGPT and Llama and like these models got released. We saw a huge problem in the market that we wanted to fix. And me and my co-founder, who also studied together with me during those years. And that's where the Nosana platform came out of. So we wanted to solve the GPU accessibility problem. And yeah, that's sort of the history.
So it makes a lot of sense. You're trying to solve a pain that you experience in uni, and so you came up with the idea with how to build Nosana. It's very interesting that you mentioned the velocity and the multiple of growth, because yesterday I was listening to Elon Musk on the All In podcast, and they just set up Colossus, which is the largest training GPU cluster in the world, so he says. And one thing that he mentioned is that even though he believes that the investment is a little bit ahead of the revenues, he has never seen a technology grow at the speed and size of any other technology currently in the world. So it's very exciting to see that you're going an independent route and actually considering an alternative way to do it for those that do not have kind of like the capex to do the investment directly as the university may have done so. So one of the things that I heard from an interview they did to you on a podcast is that you mentioned that the GPU capacity on gamers is basically bigger than the currently installed base on data center. Is that a correct reading, or I'm just misallocating ideas and interpreting it in the wrong way? Because that, for me, it's a very interesting fact. And then I realized, well, that's the reason Nosana exists. Is there's an extra, if there's more capacity in gamer GPUs, it just makes a ton of sense.
Absolutely. No, that's the case. Like, there are over 300 million gamer GPUs that can be applied to run artificial intelligence. And these models tend to be extremely efficient at doing AI inference. So this is one of the realizations we had. Like, I guess it's also kind of getting lucky, because the fact that gamer GPUs are so good in running AI makes it possible to create this open network where gamers can basically run AI algorithms and provide people access. And there are several reasons for this, right? Like, first of all, you're not allowed to put gamer GPUs in data centers because of the license. So
that's very interesting.
And then there's this production issue. So these gamer GPUs have been produced over many years and for the gamer market. While there's this sudden increase in demand for chips that just the data centers cannot keep up, and they don't have the same types of chips available as gamers. So they are kind of, if we actually get successful in bundling all these gamer GPUs and putting them in one accessible package, which is Nosana going to do, that would make for the biggest AI inference data center in the world.
But I was not aware that because of license restriction, you could not assemble them in a data center. I had no idea that was the case.
Yeah, like a 4090, you're not allowed to put in a rack, basically, in a data center rack because of the licensing restrictions there. So that's one thing that's adding to it. And maybe another example to show how like the big lack of GPUs available in the market is that for a long time, even OpenAI, the creator of ChatGPT, one of the biggest AI companies, yes, they had struggled getting their hands on enough GPUs to serve their customers. So they're basically already sucking out all the data centers. All of Microsoft GPUs are basically allocated to OpenAI, and there's just more and more of those huge companies that are trying to get as much allocation of GPUs as available, while it's this restrained resource in the data center world. And that's a big issue, because it means that there's almost nothing left for other people. So even if you would get your hands on GPUs in the data centers, yeah.
So that opens the question to another thing that I was going to ask you, but you made me realize: is there any chance that any of the large LLMs that were being trained at the beginning were not trained in a data center, but someone had to bootstrap a set of GPUs, just put them in parallel or series, and just do training with the GPUs, or GPUs are just good for inference and not for training?
Yeah, that's a good question. Like, if you get a bit more technical, the training process is different than the inference process, and yes, gamer GPUs are specifically good for inference and not for training. It has to do with the characteristics of the card, like the memory bandwidth, but mainly the VRAM available in the cards. And also that for training, if I'm getting too technical, you can let me know.
No, it's okay.
For training, you will need a lot of GPUs. working together, which means they need to be very close together. They need to be combined with like really high-speed cables between them, so you get very fast communications. And this is something that in a data center is readily available, or you can easily achieve. But when you combine GPUs from people around the world, it's very hard to achieve setups like that. So we mainly focus on the inference part, because inference scales basically horizontally. If you have like a model fits in one GPU, and we can just have 10,000 instances of that model running in 10,000 different homes, that works pretty well.
So explain. So we are neonites on this whole concept, but explain to us, because now I realize, well, Nosana is for inference, not for training, because of what you just described. But what is the advantage of having decentralized GPUs spread throughout the world to do inference? Why is this possible? Why, for example, I'll put you a simple case. So I have a friend that has a clinic, radiology, where he does MRIs, and I told him, look, at some point in your business cycle, you would need to consider doing, build an agent on any of the such LLMs, so that you can have a better diagnosis of the MRIs that you're producing. But then you would have to pay for the inferences. And when I told him that he has to pay for the inferences, he was totally lost. And like, well, you go to you connect to a site like Nosana, and you pay X amount of tokens for the inference that you're actually going to run. So basically, what I'm trying to do here is get a description of a typical Nosana client, and why does distributed GPUs work for that specific client?
Yeah, these are great questions. A few of them I will get back on a little bit later, because why it's important to run inference in a decentralized way, I think is one of these main beautiful superpowers that blockchain gives us and decentralization gives us, that are incredibly important, especially in this time where AI is growing and it's becoming such an essential part of basically work and life and for everyone. But an example of a client running this would be anyone doing inferences. But we mainly work with people running chatbots. There's this chatbot like a large language model called Llama 3, released by Meta, and it's very popular. And we run this on there's all kinds of variations, and we're able to offer like really efficient and affordable capacity for running Llama 3. And there's a bunch of companies that are looking for doing that. Some other things that we do is we make it quite like easy to run. So in a lot of cloud providers, for example, you would have to set up your own, you get SSH access into like a virtual server, and you have to sort of set things up. At Nosana, we make it very easy to run different LLMs from the command line and interact while these workloads are being put to the right GPUs behind the scenes. So we basically match the LLMs you want to run with the right GPU on planet Earth that matches your requirements. We're still in the early phase there. Like we don't do like geographical matching, like to find a GPU close to your house, but that's something in the future that we can do, that you cannot do as well in the cloud, because these are more clustered together. But yeah, so like clients would like, and because we're early phase, we're not really able to walk up to a huge like insurance company and tell them, listen, run your inferences on our cluster, because obviously there is like a big level of trust, and like you have to prove that you're like industry ready required. So we're more in the experimental phase, where we work with a ton of startups and people that are doing high throughput inferences, but with a bit less critical data and that are more experimental by nature. So it fits really well with the way we work. And obviously a lot of AI companies from the Web3 space are also interested in running on Web3 hardware, because not having to go and register your credit card at like a big cloud provider, and also the freedom aspect of decentralization plays a role for our early clients.
So in essence, a little bit of what you're doing is, I mean, if you go back to like Amazon, and when you say you connect, you're in essence balancing to different GPUs, so that an agent may produce the inference, and by agent, this could be a client, which you just said runs a chatbot or is just running it for Web3 applications. But that is the current case. I like us to think a little bit more of the future of what a typical client could look like, even though you're currently, let's say, you don't have all the GPUs or are at the scale necessary to run those clients with the necessary security or validation. But let's circle back to like my friend that has a radiology clinic. What are 3-4 use cases of like common things that people would need to run inference on?
Oh, in that case, yeah, like definitely, like the use case of your friend would definitely be very welcome on our platform. We love to work with like broad kinds of data. Like medical data is specifically a bit hard, but if you look a little bit ahead in the future, I think the guarantees we can give about privacy and security are like equal or better than you can get from going to a single provider. So we definitely would like to work with these types of inferences. And how that inference could look like is MRI scans. I'm not an expert, but they are like pieces of data that an AI algorithm can analyze and probably come up with an inference would be like probably a prediction on what's seen in that image. Maybe it can see a bunch of different like maybe discrepancies in that image or like what's wrong with the person, and it can output that pretty quick. So and doctors would probably analyze those results by the LLM to find to look at where to focus on and which ones to study closer. But that model would have to be first of all trained, and that's not happening on Nosana. That would probably happen in a lab somewhere. But
or
once
in a
that model is trained, it can be shipped to the Nosana network, and then the doctors can use it for the inferences they need.
Yeah, well, what's another case study? Because sometimes I feel that the most important thing that we need to do in our podcast is actually articulate the case and uses and the scenarios of what this technology is for. I in my personal case, have an IoT hotspot, 5G for HiveMapper, and I'm just redistributing Wi-Fi and 5G. And when people use it, they suddenly realize, oh, I don't have to go through a common carrier. But when you explain to people, for example, look, your business is just going to get better because you're going to be connected to the brain power of a trained LLM, and you don't have to. I don't know what's an H100 right now. Is it 100, 300K? I mean, what are the economics for that client that are actually going to run an inference versus actually purchasing? I don't know, the H100, going to the data center, connecting it. Why is it so much simpler to just go through Nosana than just doing the physical heavy lifting and assembling of the machine and waiting for NVIDIA if they just want to sell you, which I don't think they will, just one H100, unless you come with an order of 50 or 100 mil, you're basically just a fly in a window and they won't pay attention to you.
Yeah, of course. Well, there's only very few companies that are capable of affording the H100s and then putting them and connect and then running stuff on those H100s. It's a very difficult, pricey expertise. Plus, buying these devices is not easy either. But like there's millions of companies out there right now that want to integrate inferencers in their products, and there's so many different use cases, right? But if I don't know if people use Notion, for example, if you're typing, you have this AI assistant that's like giving you suggestions, rewriting things. Like ChatGPT is a service. There's a bunch of like competitors out there.
So every single time the agent is responding, it's running an inference, and that inference needs to be paid for, right?
Yeah, exactly. Yeah.
Unless you're on some sort of subscription model, which you could be like on ChatGPT. In fact, we built an agent that's called 10 a.m. Pro ChatGPT, and it's built from all the conversations that we have on WhatsApp and all the 100+ episodes. We just transcribe it, upload it, and then all of our users or viewers can actually run questions. But ChatGPT or OpenAI is actually paying for the cost of that inference of every single instance when a question is being asked. What are like the you don't have to disclose the full price, but how do you calculate what's the price of a question, or a question would be the equivalent of an inference, or I don't know, a 3D modeling or a mapping, or I don't know what it could be, but what is kind of like the basic economics of an inference in Nosana?
Yeah, this is a great question. A very interesting one. We're very much working on this actively right now, and there's this industry is very like competitive, and there's a lot of providers there. But if you look at like chatbots and how much you pay, you often look at the price per million tokens. So if you're like have a service that needs a lot of like an inference in a chatbot is actually producing like one token often, like one word produced in an answer. And like you pay some price per million words. Like that's very roughly how sort of technically the economics work. And at Nosana we try to have we are one of the lowest in like how much a million words cost if you do inferences.
It's very funny that you mentioned this, because it took me back into the day where translators used to price a translation from English to Spanish by the word, and so you could technically say that it's by the token. So it depends on the size of the response, the price of the inference.
Yeah. So the longer response is more expensive than shorter responses. Yeah.
That's very, very interesting. So
it take more time as well. Yeah.
So it will always be variable. And so what would a client have to do in order to, I don't know, get those responses? Do they have a bag that do they have to purchase Nosana, or how is it that they will have access to the inference? What do they need to do if they're just a client?
So in Nosana's case, you actually have to pay Nos. So you need to have a wallet with Nos, and you need to like, we are very much open source and decentralized, so we don't have any like currently like other way of paying than that you buy Nos and that you use our open source software to post jobs on the Solana blockchain. So we're not extremely accessible, I would say, to like new developers, as we're very much in this technological place. But we do offer like, so technical teams, especially from the Web3 space, can benefit a lot from our approach. And also, yeah, so that's currently the flow. But we have people building apps, and they have a lot of end users, right? We have people building virtual girlfriends, so you can chat online with a virtual girlfriend, and in the background, this will run on Nosana's GPUs. But for the end user, like, so we have application developers integrating with our GPUs to basically interact.
So if your girlfriend is not chatty, it's because she doesn't have Nosana.
Yeah. So if you stop chatting, they didn't fill up their Nosana wallet.
That's very interesting, and a very singular use case scenario. So you have to get your Nosana in order to get your inferences. That's really interesting. Okay, so it makes sense. So basically, in the future, I will tell my friend that owns this radiology clinic, well, you have to build the agent on any of the given LLMs, then connect it to the Nosana grid to be able to run the inferences, and then you will have your service to give diagnosis on multiple MRIs, X-rays, and images. Even if it's not text, images are then calculated as tokens that are actually paid in Nosana. That's pretty much the way that.
The tokens is specifically for chatbots, but we also work with a lot of image generation, like Socni is a client of ours. They are like Photoshop, but you can create all these AI generated images. It has a different pricing model than tokens, but it's like there's a lot of different types of AI that are being developed, and I think chatbots are now the most popular. But I think that's going to shift. At some point we're going to see more popular, like real world AI type inferences, I think.
So okay, so now we are on the client side. But what happens, Jesse? So I don't know. This podcast is going to be heard by a multitude of gamers, and the gamers have their computers, whatever, their GPUs idling. How can they connect to the Nosana? Let's call it main grid. How can they contribute their GPUs, and what are kind of like the mechanics? And is there a threshold? Is there like a minimum GPUs that you need in order to be there? And other than actually connecting to the grid, when do they know that they would actually get a task? Go ahead, walk us a little bit from like I have a house, I want to be part of the Airbnb. Okay, I have a GPU, I want to be part of the Airbnb of GPUs in Nosana. How would that work?
Yeah, so we are an open network, so anyone is able to connect their GPU. So if you have a device at home, a GPU, you can install, or like we have a guide online. You can go to docs.nosana.io and follow the guide and install the software. And then your GPU will be connected to the grid, we call it. So it will be there, it will be online. There is no minimum requirement actually. Like you can, if you have one GPU and you only want to contribute 30 minutes per day, you could potentially do that. Like we have a system where if you come online, like at the moment the minimum is 2 hours. So when you come online, you have to do at least 2 hours of basically being online. If you would leave earlier, you risk getting punished for basically not being very. But this is a very low requirement compared to other like networks like this.
Do people need to have a very good stable connection, or that is not a variable that bears a heavy weight into the equation of just letting the GPU run the assessment?
You do need a decent connection. It doesn't have to be extremely good. Like, but for example, you would often have to download quite large models, maybe 200 gigabytes of like files will have to be pre-downloaded to your computer before you can enter. So this is something that we check. So basically, once you're joining the network, there will be a few steps there where you download these models, and this can take a long time if you have like low bandwidth or low internet speed. But once it's there, you'll be able to join a bunch of markets, and the requirements for network aren't like they're not very high. You need to have a decent connection. But there is one maybe like important point to know, like in full disclosure, is that we do operate more on an open market principle. So what our clients need is where there will be a lot of work that you can do. So if you come like with a very old or not like a laptop GPU model, at the moment we don't have much demand for it. So it will basically be idling there. But we have we have some data on the types of GPUs and what you will get in return, and like 4090s, 3090s, even 4060s. There's a whole, and the bigger ones like A5000s, A100s, and H100s. We also there's always demand for them. So these all can be connected, and you get like a very stable, decent return if you connect one of those devices.
Just because I have my geeky side internally, there's something that I don't understand, and maybe you can help us comprehend in a better way. So let's go back to my friend that's running an inference about, I don't know, a certain MRI scan. So when he says, I don't know, give me the results, it's basically an inference that goes and hits the GPU of that contributor. Let's call him X user in Colombia. Does that GPU need to have the LLM of that model preloaded, or how does the distribution work? Does it get a piece? I'm trying to understand how does the command of the inference get distributed through the multiple GPUs that are on the network? I said on one by one basis, or explain a little bit of the mechanics of it.
So on a technical level, how we solve it is if you have a workload, you can basically put down your requirements for that workload. So you would say, I want this amount of VRAM, and I want these specific models like NVIDIA with maybe this driver version. Like you can have, or I want to have this much disk space on these models, on these devices. And then you can, we go one more level technical, you can even do a requirement for specific files that have to be present on the device. So you can say, I want these weights and these models preloaded. They can also be private models, like, or you can tell them where to find them. You can put the models behind the password, and there's quite some options there. But once you define that, we will ensemble basically devices that match your requirements, and you can also say how many you want, and then you can start running inference on them. And it will be fast because they have pre-downloaded the model. So that's how we solve it at the moment. For like a lot of almost our clients, they want really fast, basically time to first token, or the startup speed for when you put a job out there. How quickly do you get a response? We want this to be really fast, and that's how we achieve it. So we cluster these GPUs and make sure they have the right files ready for you to run your workloads.
So the client, the radiology guy, pays X amount of tokens, and then the GPUs that are distributed get, I don't know, a percentage less of those Nosana tokens, and that's how they actually get paid. It's pretty incredible if you think about it, because again, it's like the Airbnb of GPUs. I don't know if you like it that when somebody gives you kind of like that one-liner definition, but it's just like connecting or being on Booking, and if you have high ratings, then you just get the workloads, and then you just get more bookings, or in this case, you get more Nosana. I think it's pretty cool. And so now that you describe kind of like the complexity of the end user, the person that contributes the GPUs, tell us why was the reason that you actually selected the blockchain that had the highest TPS that physics actually allows it? I mean, what were the choices that made you go for Solana, and why I imagine you still believe a technology like Nosana could only happen on something like Nosana, like Solana, I say.
Yeah, that's also a good question. Like, what actually happened, like the story behind it is, we had this idea, we wanted to make this product work. We knew we needed kind of a affordable, fast blockchain. So there was only this many options. And we made a pitch for Solana, and they had a grants program. We pitched it, they gave us a grant, and that's okay. Let's build the first version on their chain. So that was the main, just because they funded it basically. But from that moment onwards, the Solana got this real traction as being the deep-in chain and ecosystem. So there was a lot of big projects going to Solana, which was for us a big help. As just the ecosystem started developing a lot around deep-in, there was a lot of like interest from the deep-in space. There was all this research being done in tokenomics in the deep-in project. So I think we got lucky there, because this right now today, I think Solana is the #1 pick. We would definitely pick Solana again to build this technology. I don't think it's the only technology that could possibly run this, but it's definitely a very good solution for us right now. And yeah, it's also a great ecosystem. So
in a great ecosystem. Yeah, that's true. I've seen Solana in the ups and downs, and the community is quite impressive. And Dario and Gordo and everybody that follows our podcast, we have learned a lot. And we're also into other deep-in projects like Shadow, which is decentralized storage on mobile, which I think is super cool. You probably should do a podcast in combination with Frank, because it is the perfect representation of what a good blockchain use case scenario has, because it just gives us endless possibilities. All right, so changing gears, Jesse, one of the things that is super complicated, I think I understand it in my head, but it's super complicated to explain, is the concept of staking on Nosana, and why you have 14 days, a month, 6 months, and a year. What is actually happening when you're staking Nosana, and why you get paid, I don't know, 26% APY? I think it was higher a few months ago, and now it's like 26 if you do staking full year. But as I understood, my friend that has the MRI clinic and the user that contributes with its GPU, what happens when the Nosana token is being staked?
So staking is meant to secure the network. So that's the tokenomics model is that it should secure the network. This is something that still has to be fully rolled out in our last phase of our test grid. So we're going into that phase like right now. So right now, when you stake, your tokens are locked up into the staking pool.
Yes.
And they will in the future be used to secure the network. And that mainly means that if nodes that your stake does get allocated to nodes, and when the nodes malperform, you risk losing those tokens. It's a motivating factor for nodes to stay honest. So that's the basics of the tokenomics model of staking. And in reward, like every job on the network, 10%, or like, I'm not sure what the percentage now is, but it will probably end up being around 10%, will get distributed to the stakers to basically reward them for that risk.
Yeah, it's pretty much as when you stake with with a Solana validator that you get X percentage of the rewards. Okay.
Yeah.
Okay.
Yeah, exactly.
Okay. So you need, so there are three variables or three actors that need to contribute to the system. Is the client that runs the inference, the GPUs that are connected to the grid, and the stakers, correct?
Yeah.
Okay. And how do you balance the three? Which one would you say is more important? Which one needs to grow the most to have mass critical adoption?
So what's the most important is just more clients using these technologies. Like the majority of all AI inferences still happen just on regular Web2 like data center GPUs. So it needs to shift, and more companies will need to start adopting Web3 technology in general, but like GPU compute. So that part is definitely where we focus on, and we're trying to grow and build like communities of developers and AI researchers that are building solutions on these types of GPU networks. Because the other sides we have, it's like there's a lot of gamer GPUs now connected to Web3 networks, and I think that there is definitely more GPUs than that there is workloads in general on any GPU network or all of them together. So the main challenge is getting that adoption of regular Web2 AI workloads running on these GPU networks.
And so, and what are you doing currently for that adoption? I mean, let's say you have this magical one, and you could come to our podcast 10 a.m. and say, "Hey, we're onboarding new clients because we reached maturity, or we reached scale, and we bring you, I don't know, a bunch of fintech companies that are running scores on the profiles, on the financial profiles of different people, and they require inferences." How would you deal with that? If something, just a big workload gets connected to Nosana, how do you stabilize it? Or you just go on, I don't know, on a road trip, a multitude of podcasts, and just begin onboarding GPUs so that they are connected to the grid? I'm always curious of how do you get to a point where you feel confident that there is enough scale.
Yeah, that's a great question. We're definitely going on podcasts and to events and take it small and speak to individual clients. And I think there's just so much to learn from what they're looking for. A lot of them are like, because we have a great pitch, I think, as deep in networks, but like we have cheaper GPUs. We can give all these guarantees that are, I think, really beneficial for clients. So I think that just that package is right. But people are very scared of certain aspects, like they cannot pay with a credit card, or being run on someone unknown's hardware is often scary. And there's all these challenges, I think, that require a lot of conversations and a lot of like education as well to onboard larger masses of companies.
Which is pretty much what we're doing here. So I mean, after we disconnect, you're going to give us the links where we can say, hey, if you want to run inferences, this is the link. Hey, if you want to connect to the grid, this is the link. So so that people, well, technically anyone that has a GPU currently can connect, correct?
That's right. Yeah, there is like, technically, yes, you can connect and install. There is like a sort of a waiting list right now. So it might take a little while before you're actually online, but it's all open there, so we can send you the links and people can connect their GPUs. And basically, when there is enough client demand, you will get onboarded on that market and start earning.
We're actually going to release this podcast on Thursday, which we'll probably be in Singapore, so we'll make it for the Breakpoint week. Jesse, do you? Is there a lot of correlation between the token price and, for example, AMD or NVIDIA results? Like, for example, NVIDIA has been fluctuating anything between 200 and 300 billion. And people are now, the conversation in the chat has been, hey, are the NVIDIA results going to affect Nosana? I'm like, well, technically they shouldn't, but have you sensed any degree of correlation between NVIDIA and you guys?
Very important question, Hernan. Thank you.
I must be honest, I don't follow these prices too much.
Which
What
you
I
and
know
you actually
is
and you
that
and you
when
shouldn't.
NVIDIA took its massive increase, then Nosana was right there, and a lot of other networks like followed in that track. I don't think it follows it to like I hear people talking about it. I don't think it and I think like crypto markets in general are more irrational.
Yes.
So it's easier to get surprised. But the trend might follow along. I cannot answer that question honestly because I don't know if in general this is still the case.
I I don't know if you've ever been to Cuba, but it's one of the big experiments in technology because after the blockade, you have cars that are from 1959 still running because people have made adaptations. Is something like Nosana a way to secure the dependence of the centralized production of chips? Let's say, I don't know, a war gets started between Taiwan and China, and then the go-to will be something like Nosana because it has the power of decentralized ability to run inferences. Is that something that you foresee in the future, or have you ever thought about it? Like, hey, I'm actually de-risking the possibility in the world of, I don't know, what was the thing that happened that you a few weeks ago by this company that I think it's also owned by that took Microsoft down? That would have never happened if I forget the name.
I forget the number.
CrowdStrike? No.
Yeah, CrowdStrike.
Right. Yeah. CrowdStrike. Yeah.
So is this a way to actually hedge our bets against a centralized world and how decentralized is actually Nosana right now? I mean, we've been talking that we have, I don't know, is it 1,000, a few thousand GPUs connected? How decentralized is Nosana, and how you actually think about it? And is this a real advantage for the world of people running inferences and having businesses in the future that depend on GPUs, but not?
Yeah, I love this question because for me, this is the primary reason why I do this, why I'm building this network, and what I find the most important that to achieve as a decentralized project. All the other parts like being cheaper and like having more security and being able to scale it's also important. But the number one reason I think what we do is important is because we can be decentralized, and which means we can, when there is a conflict in the world or when a governments decide, look, ChatGPT, you can no longer talk about maybe a conflict somewhere else in the world, like it's an illegal topic. I'm pretty sure this is already happening. I have no proof for this, but it can easily happen that the United States tells OpenAI, listen, you have to put some censorship. It has happened so many times before that the government goes towards these companies and censors the data. And this is something very dangerous, I think. And with artificial intelligence being so big, we're going to see this happening more and more. So it's very important, I think, that we get AI projects that run in a decentralized manner. But if your hardware that your project is running on isn't decentralized, the government still can exercise a lot of control over, for example, the bigger 800 clusters. And like, so even decentralizing the hardware, I think, is sort of a crucial element of having decentralized artificial intelligence where we won't be exposed to political conflicts and governments that abuse or that use their powers in their own interests. So yeah, I think this is one of the more important things DeepIn is solving, and I also think it's a very real issue that I think is happening.
On your Nosana Explorer, do you currently label or give like a little flag of where the GPU is, or you don't currently do that? Like, for example, you can see on Solana, the validators, you actually see the little dots, and it's mainly, I mean, it's Europe, the US, and a little bit, let's call it, to those countries close to the equator. But I think it's pretty cool when you actually start seeing those dots spread throughout the world, because then you start really showing the power of decentralization.
Yeah, we don't have a little flag there. We did occasionally release like a world map with all the nodes and where they were at, like a heat map, and we're basically everywhere. Like we're very distributed, which I think we're going to see that soon as well in the real life dashboard, because it's indeed a really cool and important visualization. Is the more distributed, the more decentralized, the less prone to censorship, and this is for us a really important. And we are, I think, I don't have any statistics, but we are in every continent, and definitely not too concentrated in certain districts.
Well, you probably would definitely start having a lot more GPUs in, let's call it Spanish-speaking countries after this podcast. But that is that is actually super cool, and I'm excited to see that people are starting to get it. Because look, before it was you 10 years ago studying artificial intelligence in Amsterdam, but now you're giving access to a bunch of gamers or traditional businesses that just need the power of that artificial intelligence that you were actually running. I happen to be friends with the deans of the alma mater that I graduated, and I have been constantly pushing to him. Look, you have a whole bunch of computers that are idling at night. You should just connect them to Nosana, because what are they doing? From, I don't know, students leave at 6 and they come back at 8 a.m. And so they're just idle there. And instead, you could actually be generating Nosana. But then again, you could actually figure out how to build agents for different type of businesses and then run the inferences on Nosana too. So it's a two-way window opportunity. And I think people really don't take advantage of that. Jesse, so I know there are other companies that currently are also distributed GPUs, but what makes you from the competition really different? What is the thing that you guys created or imagined that sets you apart? I mean, for me, the given was that you were actually built from the ground up on Solana, and to me, that's a very important point, because it tells a lot about the architecture and how you conceive the product. But what is it from a personal view, the biggest element that differentiates you from, let's say, people that are doing similar things?
I think most of the competitors or like the companies in Web3 that do a similar thing are often closed source and kind of focused on enterprise. Mm-hmm. Nosana is doing basically the opposite. So we're completely open source from the start. So every line of code is open source, and I think this is extremely important, because I honestly believe that if you're not open source, you're not deep in. You're just physical infrastructure, but you're not decentralized. So I think it's a very important aspect that you cannot do without. And our take is more going for the open source AI communities, and also allowing basically anyone to join our network, being able to, like, we were very an open culture type project where community contributions are very welcome. And I would say that Nosana is very different in many ways, and also the clients that we serve. So we're not doing the enterprise culture type project right now. We're more working with.
And why is it? Because most people hear the word open source, but they really don't grasp the concept and the importance of it. But why is open source so important, especially when you're running inference models or when you're performing the tasks that you're actually doing? Why is that important for a company that would that would get connected to Nosana to actually run inferences?
Because if things are closed source, that means that there is still one party that compiles the source code and gives you like a secret black box that you have to run at home. You don't know what's happening in there. You cannot audit it. You cannot see what's going on. And this company will remain in power. So whoever is building the code is basically in power of that network. And it means you lose all the decentralized benefits from using that network, because that one distributor of code can do what they want. They can censor it, and they can change things. And I think that's like a fundamental element that you need for a network to be decentralized and to be able to grow across the world. And like, people around the world could compile Nosana themselves. They could make small edits. They could run their own little Nosana markets. And like, the option that can happen in case that we as the core Nosana devs would do something people don't like, and someone else can, take what we've done before and do something else with it, I think is fundamental to the success of this.
Jesse, since you started Nosana, what has the thing that has impressed you the most about this? Let's call it this business. Is it the progress in blockchain? Is it the speed at which AI is advancing? What is the single most important? What is the single item that has like totally surprised you, and you're like, I thought this was important, but this growth is totally unexpected? What has it been?
Definitely the first thing that really amazed me was just the day ChatGPT came out. It blew my mind. Like I was completely not expecting that. Having studied artificial intelligence, I thought I wouldn't see that in my lifetime. So when it came out, I was like, that was kind of life changing.
So it's
And
not
the second
profound.
thing would be when the open source model got released by Meta, because I was just just the whole open source community around AI development, it's huge. And people around the world are like making changes to Llama and making their own models. And the fact that we're now competing with basically the closed source models created by the tech giants and the open source communities, which are creating more innovative and more performance solutions even than tech giants, I think is yeah, it surprised me a lot, and I love it. And it's
I like that answer because it made me think like, so what are the next things that you expect that are going to happen in the next, not even 10 years, but maybe 5 or 3 years, that are actually going to be solved, that are not being solved at present time through companies like yours or through services like yours? For example, I don't know, better diagnostics in X or Y, just better trading solutions. What are things that you said that you did not expect ChatGPT to happen in your lifetime, yet you saw it? And what are the things that you are currently foreseeing that could actually happen because of the way of companies like yours and the advancement of AI you think will actually happen in the future?
What I think is gonna that's a great question. I think what we're gonna see is, and it's like we might not even be close, but where we see AI more being embodied, so where it goes outside of a chat window, but becomes more like vision driven, but maybe even in robotics integrated, I think embodied artificial intelligence and like true intelligence type machines might be possible now. So I'm there to think about it. And I do think that the innovation we're seeing in open source AI is making that possible, because the amount of experimentation happening on all these new models being created, it goes way beyond what's happening in LLMs right now. Like there's all these other models that can interpret vision and sound and have to combine this, and we need to change the representations that are being used in order to allow a chatbot to be more than a chatbot, because it's not really intelligent. It's just really good at typing words, but not at like comprehending yet.
Yeah, that's one of the things that we always talk in our chat. Most people have, I don't know, an idea of how to estimate when things are going to be 2 or 3 times better, but they have no way of how to conceive a world where a current problem exists is now 10 times to 100 times better. And that's the power of what artificial intelligence is, and what companies like yours are actually allowing people to have access to, because you're just the bridge that allows people to have access to that AI, and I think that's quite amazing.
Exactly, and what we want to do is just remove that barrier. So when you have a bright idea and you want to experiment with a completely new model, and you need X amount of GPU power, you wanted to make it really easy for people to get that GPU power. So that's
that's pretty cool. Does Nosana mean anything? Is it the short for something, or is just the name you came up with?
The name, there's also a bit of a story. Like it used to be called Nostromo, which is a sort of an automation engine. It's also a novel about a Latin American country, and Nostromo is like this personality in that novel. It's also the spaceship in the movie Alien. Anyways, I like this name, and that's where the name came from.
Okay.
And then we combined it with Solana for the pitch, so that was kind of the when we went there.
Nostromo and Nosana. That's pretty cool. That's pretty cool.
That's where it came from.
Dario, I think we covered everything we wanted to touch base with Jesse, and this has been amazing. Again, let me reiterate, you you probably don't have a grasp of how people are actually studying this in other parts of the hemisphere, but you will begin to see a different set of GPUs being connected to your grid. And the example that we just discussed, the radiology clinic, when you break it into something that has a day-to-day operation, people start realizing I can actually connect and benefit from the power of AI and something like Nosana. Just to end, when do we go mainnet? When would that happen, or is it still in the works?
Like during breakpoint, we will announce something.
Okay.
So before I cannot spill too much, but we will come up with these announcements pretty soon. Perhaps when this episode drops, there's more information out there. But do follow us. And
we will definitely. Yeah, should people follow you, or should they just follow the Nosana account on X?
You can follow me as well. I'm just starting out on X. I'm not too active, but definitely follow Nosana. It's more important, more news there.
Excellent.
Yeah,
Excellent.
we'll make sure to share the links.
Yeah, well, Jesse, it's been a tremendous pleasure having you. We've learned a lot. You cleared out a whole bunch of doubts that we had, and to me, this is a very exciting technology, and I think Nosana will do great. And hopefully, we can do, I don't know, an episode in 6 months or 8 months, and we just see what the current progress is and how things have actually evolved in Spanish-speaking countries. Even though this podcast is in English, but our audience is mainly from this side.
That would be great. That would be great. My pleasure. Thank you so much for having me.
All right, man. Thanks a lot.
Thank you.
Okay, cheers.
Bye-bye.
See you in Breakpoint. See you in Breakpoint, man.
Yes, see you in Singapore.
Token 49 in Breakpoint. Sí, perfecto.